Right, go for it, Siva.
Two capacitors initially uncharged are connected in the following circuit.
Describe it to me. It's like there's two here like this, is it?
Yeah, then there's a switch on the top.
The switch between them?
Yeah.
Yeah, like you can switch between that or that.
No, it's just one switch.
Okay, I see now. So it's like you have a switch here, and then there's another switch here. Okay, and then you come down to your power. How big is that power there?
6 volts.
6 volts, and then it closes back up like this. And each capacitor, how big is it?
470.
The one on the left,
I don't know, I have 220.
220 micro,
No,
nano, microfarads, and this one
470.
micro. Oh, see that. Microfarads. Yeah. That's micro, Siva. That's nano. Yeah. Alright, go for it, Siva. What's the first question?
When the switch A, which is the left one, is closed, but switch B is left open, the 220 microfarad capacitor is fully charged. How much charge is stored on this capacitor?
Okay, so that's Q equals CV, isn't it? So that is 220 times 10 to the minus 6 times 6.
1.32.
Yeah.
Times 10 to the power minus 3. Cool.
Wonderful. Okay, B? Probably the same thing, is it?
Switch A is then opened and switch B is closed. Charge is allowed to flow until the voltages across the capacitors are equal. What is this charge stored in the 220 microfarad capacitor?
Interesting. So they've opened A, but now they've closed B. So you'll have a current that flows now around like this. And this has the same charge. These are in parallel. Yeah, good. Good. I was hoping nobody would ask me this. Because when I did this question last year, I was convinced that they were in series.
What?
Yeah, good. They're actually in parallel. Because, they're like this. But at the same time, I'm feeling like, no, but they're in series because they're just lined up in one loop. But I think, and I honestly don't know, because I can't decide if it's series or parallel. I just know because I've seen this one before that it's parallel. And the only thing I can think of is they were in a parallel arrangement in the beginning, in the original circuit. But I'm not satisfied with that answer, and I understand if you're not satisfied with this answer, and I need to find a good reason why we think of these as being in parallel. And they really, to me, feel like they should be in series, because it's just one loop, But let's continue as if they're in parallel, and I'll have a think about it. So, when two capacitors are in parallel, what do you know about their what do you know about them when they're in parallel? They have to have the same voltage. That's one thing. So we'll say V1 equals V2. What about their charge? Well, the total charge will equal the charge in the first one plus the charge in the second one. Okay. What else do you know? Oh yeah, you know how to get their total capacitance. The total capacitance is C1 plus C2, isn't it? Right, let's do some calculations. So what's the total capacitance here? If I add them together, that would be 690 microfarads. Yeah? Now the total voltage would be Q over C, which would be 690 times 10 to the minus 6 over... No, sorry. I have it upside down, don't I? Q over C, and the Q I know the total charge, I just worked it out. It's 1.32 times 10 to the minus 3. The reason that's the total charge is because you disconnected the cell. There's no new charge that can come into the circuit. The C is 690 times 10 to the minus 6. So what's the voltage here? Do you have this here? 1.913 volts. Is that the answer in the market scheme? Yeah? Yeah. Yeah, why are they in parallel and not series? Oh no, I know, but I'm still thinking about the parallel and series part. Let's finish it and go back to that. C.
I know it's the same. It's they're asking for.
Oh.
Right? They're asking for the charge Q equals C.
Oh, not the voltage?
Charge stored on the 220 microfarad capacitor.
Ah, sorry. Okay, so that's Q on the 221 equals CV. So the C is what's the C for the 221, isn't it? And the voltage we said is 1.91. So what's that, about 4.2
times 10 to the power minus. I can't read my handwriting.
minus 4 coulombs, huh? That's 420 microcoulombs. Is there more to it? I'm going to do part B again, and I want to see what would happen if you say that they're in series.
I did that.
And got the wrong answer. So there's no point in you doing it then, and hoping that you might somehow, by some miracle, get the same answer. It has to be parallel. You did what I did last year when I did this in front of the students. And then when I discovered it was parallel, it shocked me. But I can't give you a good reason other than it's parallel in the original circuit. I know it's wrong, but I just want to see what happens if you do it in series. I just want to see. But I know it's wrong, okay? So if we were imagining that they were in series, you have one here and one here. And this guy is charged up. And what was the charge, did we say? What was the charge? 1.32. The charge? 1.32?
Times 10 to the power
Negative 3. Okay. And then this, what's its capacitance here? 220 micro, and this one here is 470 microfarads. Right. Right. What did you do first? You can say this is Q1, this is Q2, and did you say this is equal to 1.32? Yeah. I suppose the thing is, if this is 1.32, this is full, and this one is empty. So we really want to think about how the second one fills up. And let me just call that Q. So that's plus Q, that's 0, that's 0, that's 0. How wrong was your answer? Like,
I forgot.
yeah. 1.5. And they want the volt. What do they want? The charge in the first one, is it? And what answer did I get? 420. Was it? 420. 420. Yeah, okay. I need to do some Googling to find out why we have to consider this as parallel. It just so doesn't work in series.
Maybe if it's series, then at first the second capacitor will be charged up. So
Yeah. You have to charge up the second capacitor from the first one.
I mean, it's in the beginning. If you charge up the first one, then the second one will be charged up too. If it's in series.
Yeah.
Why doesn't it look like parallel? I thought it was clear.
No, it is parallel. It is. I'm just trying to figure out, like he did as series, and it doesn't work. And I know it doesn't work, but the question is, why doesn't it work? Because it looks like it could be imagined to be in series as well. It can't really be in series and parallel at the same time. This is V1. This is V2. V1 does not equal V2. You know the total voltage, do you? No, and this is Q1. This is Q2. I don't know. I don't know. I'm sorry, Matt. I can't give you a reason why we can't imagine them in series. I kind of feel like this guy discharges and this guy charges up, and this one charges up that one, you know? And they'll charge it up until the voltage is equal. Q equals CV, V equals Q over C. So could you say Q1 over C1 equals Q2 over C2? No. Yes. No. No. Series definitely doesn't work, and I don't know why. Okay.